That's better. So we're going to demystify a little bit Haxe JavaScript and look how it is in the inside. So we're going to discuss how we use JavaScript from Haxe and use Haxe from JavaScript. We'll look a bit at the internal secrets. So I'm going to go through the different basic blocks that are needed to understand all that. It's how it is in vanilla JavaScript, how it works using Common JS to create modular code, and how it maps to and looks like in Haxe. And finally, how we make the two worlds communicate, because they will need to interact. So to go through that, I've taken a simple example of a modular application. So we have an entry point app and a menu component. Hopefully the code is not too complicated. So do I explain it? So we're using the menu component to render. It's a very simple static function. And in Haxe, you know, Haxe JavaScript, you have to make sure your JavaScript is in order, everything is global. Technically, it all goes. It goes in the global scope. So it's as if you were writing literally window.menu, window.menu.render, and you know the global scope is it's kind of messy. It works. That's how we've been doing a lot of good things. And but you know the JavaScript community has defined new interesting patterns. So to avoid your code and declarations to leak in the global scope, you can put them in a private scope. And a function is a private scope. And you can make it an auto-executable function, and your script inside this private scope will be entirely private. So that's how you can do an anonymous script where you can declare functions, declare variables, and it exists only within this function. And if you want something to be public, you have to be absolutely explicit. And you have to say window.public something is my value. So it is the concept of encapsulating an API and exposing what has to be public. So this is our first very basic module. So it has been standardized through the Common JS working group, and they've defined the Common JS modules specification, which is an API to encapsulate private code and expose an API, and there's a way to write this code and consume it. So if you make, oh, things have disappeared. So if you make a code, so you should be seeing some bit of private code with the export. And we're missing the most important thing here. So imagine this is a bit of JavaScript, and it does export.value equals something, export.action equals something. Otherwise, the rest of the code is all private. So CommonJS says when we load a module, it is evaluated once when it is required. When it is required, it is evaluated once, and the exports are stored in an object, and every time you use require, you get this object. So literally, require gives you the exports object. And that's how it was. Oh, here it is. Yay. So you can either attach things to export or replace entirely module.export. And so it was popularized by Node.js, where this was the only way to create modular code, and people wanted to use it in the browser. So let's imagine our menu app application where we literally just drop the CommonJS module API, which is describe what is going to be public in the menu, exports.menu equals menu, and in the main application, menu equals require menu, and we can get the exports, use the object, and everything else is private. All is good and well. However, that doesn't work in the browser. So in the browser, we have to transform it in a way that is browserified, and that is called bundling. So menu.js and app.js become source files, and they get transformed and bundled into an output, which is the bundle. That was really the beginning of the real way to make applications. And I want to reiterate that. So the bundling process is taking an entry point, climbing all the requires of the code, gathering all the modules, transforming them, and emitting a bundle. Remember this schema because it would come back. So there are a lot of bundler because technically it's not terribly difficult to bundle. It's an interesting bit. You can do that manually if you're curious. So if you're curious about how things work, I suggest that you try to make your own manual hands created bundle and your hands written require function. That is really not that complicated. So browserify, this is literally, we want to browserify CommonJS, which was the idea. Kind of the granddaddy, the industry standard, obviously Webpack. And you have a few other smaller players which have their specificities, like being smarter by collapsing the CommonJS API and new kids on the block. So that's for the introduction. That is JavaScript, modular, vanilla, or with CommonJS. So what happens in Haxe? In Haxe, we compile the code in a way which is, we tell the compiler to pick the entry point, then follow all the imports, gather all these imports, transform them in a way that is usable in JavaScript, and combine them into a bundle. And that is, pretty much the JavaScript bundling process, but for Haxe code. So you can map that in your head. So the JavaScript bundling process is what the Haxe compiler does. So it's interesting to look at the compiled code. It's quite useful to understand how it maps. And by default, so far, so the Haxe compiler emits a fairly classic ES5 prototype code, where the constructor is a function, the static fields are initialized later, and the instance method and fields are the prototype. And you can imagine that all your classes are going to be transformed individually, and they are going to be put together into a bundle, which is, unsurprisingly, an auto-executable anonymous function. So everything inside is private until you decide that it has to be public. It is structured with utilities, like how to extend another class, the class declarations themselves, then all the static field initializations get together, and at the very end, it may call your entry point if you have one. That's very nice and clean. So code is private, and what is interesting with the Haxe compilation is that it's doing a universal bundle. So the place where you want to put things global, and if you need to access what is really global, are detected based on the environment. So in the browser, it will put everything on window, and in Node.js, it will, in CommonJS API, it will feed things in the CommonJS API, and it supports edge cases like the web workers. So, so far, global scope is messy, so the module systems were invented. For that, we need to bundle them, and the CommonJS module specs allows to do that automatically and formally. and we need some transformations for the browser. And this transformation is, you know, pretty much the same thing as what the Haxe compiler does. We're doing bundling of Haxe code. So now, how do we get the two worlds? Because so far we have the JavaScript world and the Haxe world, and they are so far separate completely. So we need them to interact at times. Like, it's useful. So we're going to talk about interop. So let's look at the menu component, and let's look at what this only menu component can be in Haxe. So we have a static render function in a class. The mapping is fairly straightforward. We have a class, menu, and a static public function. So far, so good, but from JavaScript, you cannot consume that. So you have to transform it. So it gets compiled into a menu JavaScript. And interestingly, this JavaScript will work both in the original vanilla JavaScript example and in the CommonJS example, because the Haxe JavaScript output is universal. The trick about exporting code, making things code public outside of the private code of the Haxe JavaScript output is expose. So expose, which takes the name it has, the type or the function has, or expose with the custom name, will do the job of making sure what you want to get public will be exported outside depending on the runtime environment. And this is slightly, I mean, with the presentation very slightly modified, what literally the Haxe compiler would output for a simple component. So you can recognize the auto-executable function with the private declarations. And this function needs the exports. So this is how in Haxe the exports are detected. It will try to say, oh, am I running in the CommonJS context? If you have an export, then you are in the CommonJS context. So we will attach to export. Otherwise, am I in the browser? Do you have a window object? If that's the case, I'm going to attach the public API to window. Finally, I may be in a web worker if self is defined. And finally, just falls back to this. So that's our detected exports. And when we have that, then in the function, in the object declaration, we can attach the declaration. So it's like export.menu equals my menu. And that is the essence of how Haxe can universally, for just vanilla JavaScript or CommonJS, expose its API. So the next bit, how are we going to use JavaScript code from Haxe? So again, there are two cases. You may be consuming global JavaScript code, or you may be consuming NPM modules, because that's what you want to do. So both will work. So if you have some very classic, you have the job to use third-party analytics or third-party libraries, and you have to call global functions, you can just go untyped. So just untype this token, and it will be generated as usual JavaScript as you would have written in your in a simple JavaScript script. You can go and type and add wrappers with nice APIs, so it's type safe in Haxe, but this is fine. So you can write extents. That's a longer topic, but you can do the job just like that. More interestingly are the NPM modules, because that's where all the cool stuff is. So NPM, everything that is on NPM is consumable as CommonJS module. That's the basic. And if you have a module or another JavaScript file you want to require, You can use the inline syntax in Haxe because it's natively supported. And that will literally generate require JS lib. It's packaged under the JS lib namespace because Haxe is a multi-target language. So when we're working with a JavaScript target, we have to say, I'm using something from the JavaScript library. And then you can use it. And the level 2 is to create full extents. So if you want to manipulate type and classes from JavaScript, then you will likely have to write extents. And no, that's a whole topic, but essentially there's a metadata to translate into the appropriate CommonJS require code. And effectively, this is literally generated as var this class is required of the class, exactly what you would be doing in JavaScript, very straightforwardly. This is exactly what gets compiled. Which means don't forget to bundle, because the Haxe compiler will bundle your Haxe code, but it's not a JavaScript bundler. So the require code will stay require code. They will not be included. The rest of the JavaScript code will not be included in that. So you need an extra step of putting all things together. And the problem is that CommonJS is a bit aging, and nowadays everything you find is using the fancier ES6 syntax. And the fancier syntax is all this weird import star as something and curly braces and why is slider not without a star, etc. So there are rules for that. You know, even seasoned JavaScript developers get confused by that. But here's the map. Here's the mapping you can do. You know, you can shoot a photo of that, and that's essentially what it gives. So star as React gives you literally the export object. So if, like React, it's an object containing functions and classes, while in some case the export object would be literally a function, like the class names to function in React. And in the case of the curly braces, it is using deconstruction, so ES6 deconstruction to obtain the values. So unintuitively, you don't have to put star as curly brace something to get the values from the export, but that's how it is. And it can be translated just as a require something dot the value you need. You have to deconstruct that yourself. And finally, the weird case is, so without the star as, it is like as if you were requiring an export object that has a default property and it's getting you the default property value. Why there's even this concept of default is beyond me. Probably to save a star as somewhere, or I don't know. Yeah, back to that. So again, don't forget, when you call require, you literally get the exports, whatever is here. It can be a value or an object. So all these import syntaxes are just syntactic sugar for the require and some either the direct object or some property inside this object. And you have to imagine that your module is that object with an ID and export, and that was is cached. And and what you retrieve. So that's just scratching the surface. Writing extents can be technical at times. Sometimes you have to take decisions. Sometimes an API that is exposed as a single object in JavaScript has to be exposed as multiple classes. So the best thing to do is to look at existing Haxe libs that wrap NPM modules, because they will have gone through the trouble of doing the mapping, and it's very helpful then for you to get started and understand. And that will be it for me. So that's the end of this presentation, but only the beginning for Haxe JavaScript developers, because there's a whole lot to look into. In particular, the infamous Webpack bundler, which has kind of mostly direct Haxe loader. So you don't have to do a manual Haxe compiler call and producing a JavaScript file. The Haxe loader is going to keep everything in memory, or more practically in hidden temporary files. And there are a few projects like Haxe Module and Haxe JS, which can go beyond the single unique file that normally Haxe does. And you can go, there are different approaches to break it down into smaller payloads to download through the internet pipes. And that's it.